Alright, welcome to this week's installment of video notes from Mr. Flugum's physical science class. Today we're going to be talking about electrons and their quantum numbers, which are ways to describe their location and activity. So these notes, you guys, will go on page 46 in your science notebooks. Alright, let's go ahead and get started. Well, folks, let's start with this. Principal electron levels, all right, PELs. You're going to hear that a lot in these video notes, so lock that in your brain is what it is. Okay, there's 7 of them, right? So there's 7 different electron energy levels that electrons can kind of hang out in, right? We've talked about over the last week or so how those electrons can jump those levels when they are excited by energy, okay, and when they drop back down, that gives off light in different wavelengths, all right? What we're going to talk about today is how those different energy levels are organized. Now, a PEL is a number, all right? It's a quantum number that helps describe an electron, and it is represented by the letter N right here, okay? So lock that in your brain. N is your electron energy level or principal electron level. All right, so within each PEL, within each level, there's one or more sublevels. All right, they're kind of divided up. And sublevels represent the shape of the area where those electrons are most likely found, most likely to be kind of hanging out. There's 4 different sublevels, and they are right here, right? They're represented by letters. So this would kind of be our next quantum number, right? So you have S, P, D, or F would be the 4 levels that we have. Let's talk a little bit more about those. All right, well, let's talk about the connection between PELs and sublevels. All right, the number of sublevels kind of depends on the PEL, right, the electron energy level. So you can see here level 1, right, only has 1 level, and that is the S shape, right, which is just a spherical shape. Okay, when you go up to level 2, you have 2 sublevels. Level 3 has 3, level 4 has 4. Now you can see that every electron energy level has an S-shaped orbital, S-shaped sublevel, right? Okay, and then you start adding P comes next, and then D after that, and then when you get to level 4, it has all 4 suborbitals, S, P, D, and F. And as you continue up through level 5 and 6, you find that that is true as well. You have the 4 different sublevels. Okay, now let's look at orbitals. Orbitals are the specific areas that electrons are hanging out in, that 3-dimensional shape, right? And when we start to get into this orbital idea, we start to look at really 3 dimensions and how are those 3 dimensions organized around the X, Y, and Z axis, all right, a 3-dimensional axis. Okay, now each different sublevel is going to have a different number of orbitals in it. So for example, in the S level, right, we only have 1 orbital. And it's this spherical like shape here, right? On the P level, there's 3 different orbitals. Okay, all right. You can see here there's 1 on the Z-axis, right? That's green. There's 1 on the Y-axis there. That's blue, and there's 1 organized along the X-axis. That's pink. Okay. Now, as you work your way up, you see D has 5 orbitals and F has 7 orbitals. Those orbitals and their shapes kind of get more and more complex as you work your way up through the different sublevels. But what this allows is because we have these different shapes and orbitals, it allows those larger orbitals, when you get up to higher electron levels, to hold more electrons. Remember that electrons are negatively charged, so they repel each other. So they can't necessarily share the same spaces too closely. Okay, now we've got these different orbitals, right, in each sublevel. Each orbital can only hold 2 electrons. Okay, so when you have the S, that's only S sublevel, right, that only has 1 orbital, it can only hold 2 electrons. Okay, P level, however, has 3 different orbitals, right? Okay, that are oriented around a different axis. It can hold 6 electrons, right? 2 for each orbital. Okay, D you can see there, and F up to 14 electrons. All right, so principal electron levels and electrons. So because we have these different sublevels and with different amounts of orbitals. Okay, that means each level can only hold a certain amount. We already kind of know this, right? But this starts to maybe put a little bit of explanation behind it. Level 1 only has a sublevel S, right? So only holds 2 electrons. Level 2 has sublevel S, right? And sublevel P. Okay? It's 2 electrons in S, 6 in P. It gives us 8 total electrons in energy level 2, right? Okay? And you can see there 3 and 4. Now maximum, right, is number 4, 32 electrons total. So guess how many 5 and 6 can hold? If you said 32 electrons, that's basically right. All right, our last quantum number or way to describe an electron is this, right? It's spin. So there's 2 electrons per orbital, right? Because they're kind of like charges and they're hanging out by each other, they need to have opposite spins. So the spin is given a value, all right? And that value, folks, is either positive 1/2 or negative 1/2, okay? Okay, so to try and sum this up, all right, there's 4 things that really describe an electron's location with an atom, okay? It's PEL, right, principal electron level, that's N, okay? It's sublevel, whether it's in the S, P, D, or F, all right, sublevel. And then it's orbital, okay? Is that orbital arranged on the X, Y, or Z axis, okay? For example, right, we've kind of talked about this one here. Is it PX, right? PY, or is it PZ? Okay, so there's different ways to describe these, and then within each orbital, whether it has a spin of positive or negative 1/2. Those are 4 ways that we can describe electrons, right? Level, sublevel, orbital, and spin. Well, thanks for tuning in. If you've got questions about this, you guys, we will talk about it on Thursday. Okay, remember there will be a quiz. If you don't understand anything from this, though, feel free to ask me, and we'll kind of try and hammer it out and make sure that you understand this. More things will be clear as we start talking about how to notate electrons and electron configurations in atoms. But this is the basic knowledge that we need in order to do that. So looking forward to see you on Thursday, and I hope you have a great night. Bye-bye.